LAMP requires only 8 to 16 videos for training on a single GPU. Dear friends, LAMP's lightweight nature also means that content creators with limited computational resource can access high quality video generation capabilities, democratizing video content creation. That the system achieves 80 FPS at 4K resolution using an RTX 4090 GPU, which is 30 times faster than each of these technologies. Presents exciting possibilities for content creators, developers, and researchers alike. And dear friends, the result is sharper textures, finer details, and overall higher quality 3D renders. Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to Demystify with Ajay. Dear friends, today we are going to discuss few advancements in AI that are pushing the boundaries of visual computing. From rendering dynamic 4K scene into real time or to generating lifelike videos and creating intricate 3D models. These innovations are setting new standards in computer vision. Whether you are a researcher, developer, or enthusiastic, these insights will provide a glimpse into the cutting-edge technologies driving the future of AI. Dear friends, let's dive into 6 major developments that are reshaping the landscape of image and video synthesis. The first paper is on 4K 4D, real-time 4D view synthesis at 4K resolution. Dear friends, 4K 4D is an innovative real-time view synthesis system designed to generate high-resolution 4K views of dynamic scenes. Unlike convolutional methods that suffer from speed limitation, this paper 4K 4D achieves exceptional rendering quality and performance using a 4D point cloud representation. And this representation is both hardware efficient and naturally regularized, ensuring smoother and faster rendering. By leveraging a hybrid appearance model and a differentiable depth peeling algorithm, 4K 4D enhances visual realism while maintaining real-time speeds. Dear friends, benchmarking results reveal that the system achieves 80 FPS at 4K resolution using an RTX 4090 GPU, which is 30 times faster than previous method. This makes it an excellent choice for gaming, AR, VR application, and virtual content creation. Additionally, 4K 4D's ability to render dynamic scenes with minimal latencies opens up new possibilities in live event broadcasting and immersive virtual experience. The authors have announced plans to release the code for reproducibility, further encouraging the adoption of these groundbreaking technology. Next, EvalCrafter, benchmarking and evaluating large video generation model. Difference EvalCrafter is a comprehensive framework designed to evaluate large video generation models with greater accuracy and reliability. Unlike traditional metrics such as FVD or IS, which provides limited insights, this paper, EvalCrafter, uses multidimensional evaluation approach. It assesses models based on visual quality, motion consistency, content accuracy, and alignments with text description. By creating a curated list of prompts using large language models, EvalCrafter simulates real-world scenarios for thorough testing. Additionally, it employs opinion-aligned scoring to ensure the final evaluation reflects users' preference. Dear friends, this refined scoring methodologies ensures that models are assessed not only for objective performance but also for user satisfaction. And towards the development of EvalCrafter highlights the growing need for transparent, reliable evaluation frameworks as video generation models become increasingly integrated into content creation pipelines. Its applications can extend beyond research to commercial use cases, providing developers and organizations with actionable insights for model improvement. Next paper, LAMP. Learn a motion pattern for few shot based video generation. Dear friends, this paper LAMP introduces an efficient few shot learning framework for generating videos from text. Unlike traditional methods that rely on massive datasets, LAMP requires only 8 to 16 videos for training on a single GPU. It uses a first frame conditioned pipeline that applies pre-trained text to image models for content generations while focusing solely on motion learning. By incorporating novel temporal spatial motion learning layers and a shared noise sampling strategy, LAMP ensures both visual consistency and stability in video generation. This makes it a powerful tool for applications like video animation, video editing, and creating motion sequence from limited data. Furthermore, its adaptable design allows LAMP to support tasks such as real-world image animation and video editing, making it a versatile solution in the creative AI ecosystem. Dear friends, LAMP's lightweight nature also means that content creators with limited computational resource can access high-quality video generation capabilities, democratizing video content creation. Next paper, Progressive 3D. Progressively local editing for text to 3D content creation with complex semantic prompt. Dear friends, Progressive 3D offers a novel approach to generating complex 3D content from textual prompts. Instead of generating the entire 3D model at once, Progressive 3D adopts a localized step-by-step editing process. Users can specify different regions of the 3D model using region prompts, allowing for targeted content manipulation. The framework also features an overlapped semantic component suppression techniques that ensures independent regions are edited without interference. This results in accurate, detailed 3D content generation. And dear friends, this Progressive 3D's region-based editing capabilities provide a designer with greater control over the final outputting, making it particularly valuable for applications in video gaming, virtual worlds, and augmented reality experience. Additionally, its adaptability to various text to 3D method ensures seamless integration into existing content pipelines, further enhancing its utility in creative workflows. Next, it is 3D GPT, procedural 3D modeling with large language model. Dear friends, 3D GPT brings the power of large language model to procedural 3D modeling, making complex content creation more accessible by breaking down modeling tasks into manageable segments. 3D GPT delegates responsibilities to specialized agent. Yes, the task dispatch agent, the conceptualized agent, and the modeling agent. These agents collaboratively interpret text-based instruction, generated detailed procedural description, and execute modeling tasks using tools like Blender. So this automation significantly reduces the time and effort required for 3D content creation. And dear friends, beyond procedural modeling, 3D GPT's adaptive approach also enables iterative design adjustments, allowing creators to refine models interactively. And its integration with Blender further streamlines content production, making it ideal for both independent and creators and large production studios. 3D GPT stands as an testament to the expanding role of AI as the creative partner in the digital design process. And today's last paper, enhancing high resolution 3D generation through pixel-wise gradient clipping. Okay, shortly specified as like PGC. Difference, pixel-wise gradient clipping is a breakthrough technique designed to improve the quality of high-resolution 3D object generation. In traditional 3D generation pipelines, uncontrolled gradient propagation can lead to texture inconsistency and poor visual quality. And here this PGC addresses this by selectively clipping pixel-wise gradient, ensuring that essential texture information is preserved while preventing gradient explosion. This method enhances the synthesis capabilities of model using latent diffusion model LDMs and score distillation sampling, that is SDC. And here friends, the result is sharper textures, finer details and overall higher quality 3D renders. And PGC's seamless integration into existing pipelines means that creators can leverage its benefits without altering their foundational workflows. Its implementation offers a significant boost for industries like film production, product visualization and game development, where photorealism and intricate details are critical. And dear friends, that's wrap up our exploration of the latest advancement in real-time 4D synthesis, video generation and 3D modeling. From the ultra-fast rendering of 4K 4D to the detailed motion learning of LAMP and powerful procedural modeling capabilities of 3D GPT, these breakthroughs are driving the next wave of AI innovation. Each of these technologies presents exciting possibilities for content creators, developers, and researchers alike. If you found this video insightful, don't forget to like, share, and subscribe for more updates on cutting-edge AI research. And dear friends, let me know in the comments which of these technologies excites you the most. Thanks for watching and see you in the next episode. Happy learning, dear friends.